this way because it's prettier. Prettier. Did you video?
Definitely recording right now.
Okay, ready?
Yep.
Okay, so this is beta oxidation fatty acids. So what we're doing is we're pretty much just breaking up fatty acids for use of energy in our body. So we can have odd chain or even chain fatty acid oxidation. So just for example's sake, we'll just do a 21 carbon fatty acid chain molecule. So we obviously know this is an odd chain oxidation. So what we have to do is we start off with a 3 carbon propionyl COA molecule. So we have to subtract that from 21 because this is our starting molecule. So we're already down to 18 carbons. Every single round we take off 2 carbons. So every single round of beta oxidation we remove 2. And so 18 divided by 2, we are at 9 cycles. And for every cycle of beta oxidation we use 4 ATP. So 9 times 4, we are at 36 ATP. And this is phase 1. But we also have this guy up here, which for every round, it makes 5 ATP. Or not for every round, this is our starting molecule, so it's going to add 5 ATP to this guy right here. So we are at a total of 41 ATP just for phase 1. Phase 2 is the TCA and ATC cycle. So phase 1 and 2 are kind of combined here. Or phase 2 and 3 are kind of combined here. So we're going to use 9 cycles, which pretty much what this means is 9 cc's. So this is acetyl-CoA. Don't mind my writing. And for these cycles, it's 9 times 10 ATP every time. This is entering the TCA cycle that we use for energy. So this is 90 ATP. So adding these all together, we have 90 plus 41. But again, this also uses energy. So not only are we making energy, this uses energy. So we have to minus 3 ATP every single time because we're using energy. So it comes down to 128 ATP per molecule every single time that this is being used. And I learned today, actually, I'll get a different color. It's cool. That our professor actually gave us a really quick way to do this, and I really wish I learned this before I learned the hard way. Well, this isn't really that hard, but for every odd chain fatty acid oxidation, you're going to do 7 times the carbon number minus 20. Or they say 19, but it's just easier to subtract 20. So 7 times our 21 molecule minus 20. And if you do that, so just really quick, that's going to come pretty much the exact, so 7 times 1 is 7, 7 times 14, and then minus 20, it pretty much just gives us the exact same. So roughly around 128, I'll do this though. So this is a lot faster. I would definitely suggest doing that instead of this over here.